Welcome to new class. The topics of discussion: acceleration oblique deceleration from velocity time graph. From previous discussion we know this is velocity axis, and this is time axis, and we know this is velocity time graph, VT graph. For constant velocity. That means velocity does not change. And the area under the graph, this area is equal to distance traveled. Distance traveled by the particle. Okay. Now, suppose the particle starts moving from velocity v is equal to, this is time axis, time t, and this is velocity. Velocity changes in this manner. That means this point corresponds to 0.00. That means the point of meeting these two straight lines. Time axis, this is x-axis actually, and this y-axis. This graph, velocity time graph, represents velocity with acceleration. And in this case also, the area under the graph, this triangular area is the area, this area. So if we want to calculate the area, you must know the distance. This distance is known as base, and this distance is known as altitude. The area of this triangle, the shaded portion, starting from this area of this shaded portion or triangular portion, area is equal to half into base into altitude. The height or altitude is same. Similarly, in case of deceleration, that means when velocity decreases, velocity with deceleration, in this case also, this is the area. And this is also half into base into altitude. Okay. So this is time axis, this is velocity axis. In each case, this is time axis, this is velocity axis. And if triangular shape, then to deduce the area, this is the formula. And for a rectangular shape, you must know that is equal to length, this is length, and this is breadth. So this is B, this is L, area is equal to L into B. In this case, half into base into altitude. So these are indispensable informations from geometry, and this geometrical knowledge is be applied in physics. Now let us start solving problems, very simple problem. And I have given you a formula. We have deduced a formula in previous video. V is equal to U plus AT. You must remember the exact meaning and the implication. What does it mean? Exact meaning. What is the exact meaning? V is equal to, sorry, V is equal to final velocity U is equal to initial velocity. Now let us solve a problem, very simple problem. A particle moves with initial velocity 3 meter per second, and after 3 seconds the final velocity is 6 meter per second. Find acceleration. This is acceleration in brief, ACCLM. Now we have the formula. We know V is equal to U plus AT. From this problem, this is initial velocity U. So at first you must write this. U is equal to 3 meter per second. V is equal to 6 meter per second. And time is equal to 3 seconds. T is equal to 3 seconds. Remember this, in case of problems of physics, you have to write down the numerical value. This is the numerical value, and this is the unit, meter per second. So you have written here numerical value and the unit also. Velocity as the unit, meter per second or kilometer per hour as given in the book. So putting all the values in here, in this equation we have, or write down 6 is equal to 3 plus 3t by interchanging rules of, by interchanging 3 plus 3t is equal to 6, or 3t, sorry, 3a, at, value of t is given, this will be a. Okay. 3a, 3a, 3a is equal to 6 minus 3 is equal to 3, or a is equal to 3 by 3 cancelled is equal to 1. Actually, the unit of acceleration will be meter per second square. If we follow the units, then we will get more elaborately. If we solve this problem, including the units, then this is very simple method. Elaborately, we can write all the units associated with the digits. So this is 6 meter per second. This is 3 meter per second. 3 is equal to second. That means 3a from this line we will get ultimately meter per second square. 3 meter, 1 meter per second square. So acceleration is equal to acceleration A is equal to 1 meter per second square. This is the answer. 1 meter per second square. Per second square. Actually, meter per second by second. So meter per second means meter by second. 1 second is there and then another second is there. So second into second, second square, that is equal to meter per second square. So this is the explanation for unit of acceleration. So this is a very simple problem. Initial velocity is given, final velocity is given, formula is given, and the time also given. Now acceleration can be easily calculated from your calculative aptitude. Actually, you have to learn these problems by heart, and this is the simplest, most simple problem. Now we shall start our journey from simple to complex. From simple to complex. Now second problem. Second problem is like this. A car moves with speed v meter per second. Suddenly, suddenly brake is applied. The car starts to decelerate at a rate y meter per second square. Notice here, the unit of deceleration or acceleration is meter per second square. Notice this. Find time taken by the car to stop. So, this is another problem. Answer will be like this. From the question, you may write down initial velocity is equal to v meter per second. So in place of u, it is v. Okay. And when car stops, final velocity. is equal to 0 meter per second, not 0, not only 0, it will be 0 meter per second. Okay, and deceleration is equal to y meter per second square, and time taken is equal to t. We do not know what is the value of t, so that we do not know is under such a sign. Okay, now answer. We have the formula. We have the formula V is equal to, sorry, V is equal to U plus AT. This is the fundamental formula. And we know this is final velocity, this is initial velocity, this is acceleration, and this is T. Now, A may be acceleration or deceleration, both. So it is a new concept to you. So I am writing here. A indicates A. A is equal to acceleration, or A may be deceleration. When it signifies deceleration, the formula changes. The formula changes to this form. V is equal to U minus AT. So this formula is applicable for acceleration, and this formula is applicable for deceleration. Okay. As this case is a case of deceleration, we must use this formula, but the meanings of the notations used, that means V, U, A, T, will remain unchanged. The meanings will remain unchanged. Same meaning it will be here, but the form of the formula will be changed by from positive to negative. Okay. So this is the formula. Now, final velocity is equal to 0. This is 0. Initial velocity is equal to, in place of u, it has been given v. So v minus, in place of deceleration, that is y, and t is the required time. So 0 is equal to v minus yt, or yt is equal to v, or t is equal to v by y. So time taken to stop the car, t is equal to v by y. That means velocity by acceleration. So this is the answer. Hence we can write here more explicitly or more clearly the time taken to stop is equal to t is equal to v by y. Now v have any meaning. It may be 3 meter per second, it may be 6 meter per second, it may be 5 kilometer per hour, or anything else. This is an algebraic expression, and you may take any value of the variable or the quantity and solve the problem. So this is the answer. This is the answer. This is okay.